In this project, I studied the collision of galaxies, and more specifically I wondered what happens when galaxies collide, and how do we know that galaxies will collide, and how do we know when they will happen? So the first important thing to understand is exactly how big a galaxy is. Our Milky Way, for example, has a radius of 52,850 light-years. 1 light-year is 5.88 trillion miles or 9.5 trillion kilometers. And you would have to drive 24,901 miles, or 40,075 kilometers, to drive around our Earth at its widest point. So galaxies are humongous. Now, galaxies are drawn together by a mutual gravitational attraction, and this attraction cannot be seen but felt. Galaxy collision occurs often and is considered natural. In fact, it is believed that it is the main drive of galaxies' evolution in time. Observing the collision of galaxies is also a bit difficult because it takes billions of years for the process to be over with, so our mortal selves can only observe a snapshot of what is actually happening. But we still have come a long way. In the 17th century, a man named Charles Messier was observing comets and found strange fuzzy objects that didn't seem to be comets at all. It wasn't until the 1920s when we finally got an explanation. A man named Edwin Hubble debunked a previous theory that these fuzzy objects were clouds of dust in our Milky Way, and he used something called a Cepheid variable star. So let's start off with an example. Imagine you're looking at a flashlight that is 10 feet away from you, and you measure exactly how bright it is. So imagine that the flashlight then moves away from you, and you're not exactly sure how far away it is from you now. So you use how much more dim it's become to figure out exactly how far it is from you. This is kind of how the Cepheid variable star works as well. So a Cepheid star will pulsate. Its luminosity, when it does pulsate, depends on the length of these periods. Now, if it's brighter, that means it has a longer period, and vice versa. And so the time that it takes for a star to brighten and fade will dictate exactly how many light years it is away from our Earth. This is called the PL, or period luminosity relation, and it helps map out the size of our Milky Way. So Hubble used this relation with the Cepheid stars in a certain cloud of dust that he was observing. This would later be called the Andromeda Galaxy, and he discovered that the stars he was observing were too far away to be part of our own galaxy. So we knew that there were other galaxies. Now we needed to know how to measure the movement of galaxies. Now, with galaxies being so large and far away, it would seem impossible to examine their movement. But examining the spectrum of light coming from a galaxy, you can determine if it's moving towards or away from us, and exactly how fast. The Doppler effect is the change in frequency of a wave when there's a relative motion between the source of the wave and its observer. Believe it or not, this was proposed by a man named Christian Johann Doppler in 1842. The first important thing to understand is what a wavefront is. It is a surface containing points affected in the same way by a wave at a given time. But if you notice the example I have there, each wavefront is kind of a shell by the original source of the wave. So essentially, anyone within that shell who is standing in that area is affected by the same wave because from all sides they are moving the exact same way. So let's say that there is a stationary source, and that source is emitting waves in all directions with a constant frequency. Anyone who stands still near the source will encounter each wavefront with the same frequency. But say the source moves. The wavefronts will bunch up in front of the direction that the source is moving. It will also become spaced out behind the source. So if a person is standing in front of the direction that the source is moving, they will experience a higher frequency of these waves. And a person that is behind the moving source will experience a lower frequency. Now, we must understand that waves come in many different forms, and one of these is light. The frequency of these waves of light determine the color we see. Higher frequencies of light appear blue, and lower frequencies of light appear red. This is referred to as blue shift and red shift. Hubble observed the light from distant galaxies and matched that with the predictions of the Doppler shift. If stars and galaxies are traveling away from us, their color will move toward the red end of the spectrum, and if they are moving towards us, their color will move toward the blue end of the spectrum. So we can finally know how fast and where a galaxy is going. Let's talk about the actual collision of galaxies. There are many different possibilities and outcomes of galaxy collision. Some galaxies may even just interact with each other when they pass by. Clouds of gas inside each of them may become compressed and collapsed and will form new stars. An important bit of information to remember is that stars will almost never collide. It's true that galaxies contain around 100 billion stars, but the stars are puny compared to the average distance between them. So star collision is nearly impossible. However, the space between the stars is full of gas and dust, and as previously described, the friction between the gas and the colliding galaxies will cause shock waves, and that can trigger star formation. Galaxies can also pull on material from other galaxies and disrupt their form. Two spiral galaxies can come together to form a new type of galaxy called an elliptical galaxy. While spiral galaxies have arms, elliptical galaxies look like an oval-shaped disk in the sky, and their brightness decreases as you go outside the center. They are the most abundant in the universe, but they are described as old, dim, broken, and dying, because of their small amount of star-forming gas. Galaxies are essentially considered dead when they can no longer form stars. The last 3% of galaxies in the universe are irregular galaxies, and other galaxies can warp or change their shape. Our galaxy, the Milky Way, has been predicted to collide with Andromeda in around 3.9 billion years. But thanks to Europe's Gaia spacecraft, the predicted collision will be less extreme and will take longer than expected, around 4.5 billion years. So the Gaia team mapped out how the Andromeda and the other galaxy, called Triangulum, have moved through space, and suggested that the predicted collision will be more of a side sweep. Andromeda and Triangulum are also close enough to be interacting gravitationally, which may also affect the result. Plus, Milky Way will actually hit a large magnetic cloud before that, around 2.5 billion years from now. So that was my project on the collision of galaxies. It was super fun to learn about, and I hope to learn more in the future.